Hey guys, welcome back. So what we're looking at today is 1.7, chew on this. So we're going to go ahead and jump on into that. Our primary focus of this is going to be looking at geometric sequences and specifically looking at the fact that they have a common ratio, even if they are decreasing. So we're used to them increasing, but they can also decrease. So we'll go ahead and jump on in. So we want to find the missing values for each arithmetic or geometric sequence. So they could be either or. Then underline whether it has a constant difference or a constant ratio. State the value of the constant difference or ratio. And indicate if the sequence is geometric or arithmetic by circling the correct answer. So if we look at number 1, we're going from 5 to 10 to 15 to something to 25 to 30 to something. So what are we going up by every single time? Are we adding or are we multiplying, first of all? We are adding, so we have a common difference. So we're going up by 5 each time. So 5, 10, 15, 20, 25, 30, 35. And so being as we have a common difference and we're going up by 5 every time, we have an arithmetic sequence, not a geometric. So remember, with geometric sequences, it's all about you're either multiplying or dividing. So make sure you look at between more than just two numbers. So don't just look between, 5 and 10, we must be multiplying. No, because then if you look from 10 to 15, you're definitely not multiplying. So make sure you really look at the whole sequence, not just the first two, and then put whatever the difference is between those. Okay? So be very careful with that. All right, the next section, determine whether the given information represents an arithmetic or geometric sequence, then write the recursive and explicit equations for each. So once again, you're going to have both kinds of equations. So number 5, 2, 4, 6, 8. First off, is this arithmetic or geometric? It's arithmetic because we're going up by 2 each time. So now equals previous plus 2. Now, for our explicit equation, I've noticed some of you are having a few issues with this, so I'm really going to explain this here, hopefully. Whatever this value right here is, that represents your slope. An explicit equation is always going to start with f of n equals whatever this number right here is, so 2, and then we put our variable n. Now, we can't just leave it there. In some cases, that might end up being what the equation ends up looking like, but we always have to double check. So in our sequence, the 2 represents our first term. Each term we move up, we are adding 2. But when we write an explicit equation for an arithmetic sequence, we have to use the 0 term. Must use 0 term for arithmetic. So what that means is we have to find the 0 term. So if we're moving through our sequence and we're moving to the right in our sequence, it's going up. So to go backwards 1, we're going to have to subtract. So 2 minus 2 now is 0. So our 0 term is 0. So we can write 2n or we can write 2n plus 0. Now having that 2n plus 0 helps you remember that, okay, we have to figure out what the y-intercept of our equation is, because the arithmetic sequences, you can think of them as linear equations. You need slope, you need your variable, and you need your y-intercept. You have to have those 3 things. So use that to help you. Now, if your y-intercept is 0, you don't necessarily have to write the 0 there, because it doesn't change it if we don't have it, but it can be a very helpful reminder for you to have that to help you remember, I need to find that zero term, okay? All right, we're also going to do number 6. So once again, like I said before, make sure you look at the whole sequence, because with this one on number 5, it's going 2, then 4. Guess what? Number 6 also starts 2, then 4. But this time it's 2, 4, 8, 16. So what are we doing this time? We're multiplying by 2. So now equals previous times 2, which means this one is geometric. Now, for our explicit equation on this one, once again, it's still going to start with the f of n. But the difference between the explicit equation in geometric versus arithmetic is we don't have to have the zero term. We can use any term we want to start this equation. So I'm going to use the 2. So that's our first term. Then we put the rate or what it's changing by each time. And then the exponent. That's where our variable goes, is in the exponent. And it's n minus 1 because this was the first term. This 2 here was the first term. If I would have used the second term, so or times 2 to the n minus 2. Whatever term you use is going to take and alter your exponent to look as such. So it'll change it. So if you're using the second term, it's minus 2. If you're using the third term, it's minus 3, so on and so forth. If you're using the 100th term, guess what? It's n minus 100. So be super careful with that. I know I've seen some definite confusion on that for some of you as you were working on the previous assignments last week. So be careful. All right. The next thing we're looking at. So all of these are just like that. So you have a table. In the table, time represents your term numbers. This means term 1 is 3, term 2 is 7. So it's just 3, 7, 11, 15. That's your sequence. This one would just be 5, 8, 12.8, and 20.48. That's supposed to be at 20, not 21. 20.48. So use that to help you think about those, because I know some of you have had some issues with the tables and getting confused as to what numbers are what. Then you've got 2 word problem ones. It will tell you anytime you're dealing with interest, guess what? It's going to be a geometric sequence. So keep that in mind. All right. The next section is looking at slope. So for the following problems, 2 points and a slope are given. Plot and label the 2 points on the graph. Draw the line segment between them, then sketch on the graph how you count the slope of the line by moving up or down and then sideways from one point to the other. So we are going to look at number 13. So we have the point 2, negative 1. So we go over 2 to the right and then down 1. So there is A. Then we have B is 4. So 1, 2, 3, 4. And then up 2. Remember, when we have ordered pairs, first term is always X, second term is always Y. Now, it says that our slope is 3 over 2. So that means we're going up. Let me change the color here. We're going up 1, 2, 3, and over 1, 2. So we have our slope drawn out. So that's what the slope of this line would be, and that's this. I'm going to attempt to draw this line. I make no promises. My abilities, and that is point B, point A. So that's what you guys are going to be taking and doing for these. You're going to be drawing the 2 points, then drawing a line between them, and then showing this 3 and this 2, or whatever the slope may be. You're going to show how you know that that slope actually worked, okay? All right, and the last section. For the following problems, 2 points are given. You're going to plot and label these points on the graph, and then count the slope. So the slope isn't actually given this time. Notice there's nothing there. We have to find it. So for 16, we have c equals -3. So we go 1, 2, 3. And then the y value is 0, so we stay right there for our c value. D is 0, 5. So we're on the y-axis, and we're going up 1, 2, 3, 4, 5. Now we want to draw the line between them. I'm going to attempt. I make no promises how good this is going to look. There we go. Okay, so this is our C value. This is our D value. Now we need to look at the slope. So we're going up 1, 2, 3, 4, 5. And we're going over 1, 2, 3. So that means our slope is 5/3. That's what you guys are doing for this section. So start by graphing the 2 points, drawing the line between them, and then drawing out that slope triangle. So how much you're going up, how much you're going over. Then make sure you write the slope down, okay? All right, if you guys have any questions, feel free to ask. Your video keyword for this lesson is geometric. Geometric is your keyword for this lesson. Have a great day, you guys.